Hey everyone, it's Mojtaba here. In this part of the tutorial, we're gonna dive a bit deeper into how paths work in the program. And along the way, we'll follow the de novo ticket to get a better understanding of the logic behind choosing between the non-happy path and the happy path. So, in the last episode, we figured out that this file is actually the de novo ticket. Now, we're gonna go into the program and track it down. Now logically, the OEP is the endpoint of our happy path. But this time we want to find the non-happy path. All we have to do is change one of the system specs that de novo uses as a fingerprint, and boom, we're on the non-happy path. We saw in the previous part that the getUsername function is used, and its result is part of that fingerprint. So now, we just need to tweak that result. As you can see in the docs for this function, the first parameter is a buffer where the result gets stored. My username is PSD. Let's change it up a little. And just like that, you'll see the de novo ticket gets deleted. So it seems like the non-happy path works like this. If the system specs don't match the ticket, it deletes the ticket and requests a new one from the server. Now, all we need to do is hook the function that's used to delete the file, and we'll find the endpoint of the non-happy path too. Alright, for our dirty dancing, we need to find a spot before the program decides between the happy and non-happy paths. We know that point is probably right after the de novo ticket is read, so let's go find it. In the last episode, we saw how the ticket is read. First, the path file exists function is called, and if the file exists, it gets read. So now, we just follow the data after it's been read. Here, you can see it's just copying the data to another location in memory. And over here, it's reading the data. You can tell it's a loop because we keep coming back to this same point in the code. It's probably decrypting the data and writing it somewhere else. One of the easiest ways to track this is to look for the memory address in the registers or on the stack, since the destination address is probably right there nearby. And here, you can clearly see the data being decrypted. As you pay a little attention, you'll actually see how it's working under the hood. Alright, now we just need to follow this memory address again to see how de novo actually uses it. Over here, it looks more like it's counting the length of the decrypted data. Probably some kind of validation function going on. You'll see that this function is actually reading the data. But here's the interesting part. This function isn't obfuscated at all. You can even see exactly what kind of information it's extracting from the de novo ticket. We can drop a breakpoint at the start of this function so we can come back to it later when we're ready to build a keygen. So it looks like the de novo ticket has four main structures. AI, which stands for App ID, UI, that's User ID, GT, Game Token, and OL, probably short for Ownership List, which most likely refers to DLCs. It's pretty clear that the Game Token and Ownership List are base 64 encoded. Now, for example, if we follow the Game Token, we can actually see its decrypted form too. And then, it copies the data again. Seems like right here, it's trying to decrypt it. And again, by poking around the registers, you can find the location where it's writing the decrypted values. You don't even need to deobfuscate the code for this. Let's follow the data one more time. You'll see it gets copied to yet another part of memory. And here, it looks like it does one more round of decryption after the copy, which isn't really important for now. Alright, I think that's enough for this part of the tutorial. In the next episode, we'll probably finish up the dirty dancing and figure out where Denuvo actually stores the fingerprint. Thanks so much for watching this far.